All right, everyone, now that we know how to find the length or the width, if we have other information such as the perimeter, we're not going to use those skills to help us find the maximum area based on a set perimeter. Let's look at an example. The first example we're going to look at is the garden fence. So let's take a look and read here. Marion's building a garden. She has 20 meters of fence. She wants to enclose the largest or maximum possible area. The fencing comes in 1 meter lengths. Okay, all that means is that we're not going to have a decimal. So that's good. All right, so if we take a look at this, maybe we'll draw ourselves a little picture. Tiny little sketch just so we understand what's going on. Okay, there's lots of different areas that 20 meters could represent. So this could be the first garden. You could have a 1 meter by 1 meter by 9 meter by 9 meter. You could have a garden that looked like this. Length of 2, length of 2. Here would be, it would be 8 by 8. Just some examples, just so you can see that as we move along here, there's different sizes we can see with our eyeballs as we design our garden in different ways with different lengths and different widths. We can see there's different sizes of garden or different areas of garden. Well, we want to know, what we're trying to find out is what length and width can I use that will maximize the amount of garden, that will give me the biggest garden of area on the inside. Now how we're going to do this is we're going to use a data table to help us figure out and glean from this table which which width and length will give us the maximum amount of area. Now we're told we have 20 meters of fence, so no matter what we do, we have to make sure that the perimeter is always 20 meters. So let's start with a width of 1 meter. We can't have a width of 0. That doesn't even make sense. So we're not just going to have, we're not going to have one fence 20 meters long. That doesn't even make sense because you won't even have a garden. You have to enclose a piece of land. So the first one we're going to look at is perimeter is 20. Width is 1 and length is 9. Well, that represents that example right there, width, length. Now, when we multiply width times length, we get 9 meters squared. All right, so far so good. Now what we're going to do is the next example, we're going to continue our table with a width of 2. So from the previous content, we knew that perimeter equals 2 length plus 2 width. So that should be 20 equals 2 width, which is 4, and then 2L, and we don't know what L yet is. So using our inverse operations, 20 minus 4, and then we divide by 2. I'm not going to go through all that because that's something that you're going to have to go through for each of these. And take your time doing that. So if you're not understanding how I'm getting this length in my head, I'm just doing the algebra very quickly in my head. You'll have to do it on paper just because I've been doing this for 20 years, but I'm not going through the process. You can look at the previous video for that. Okay, so what is the area of a 2 by 8, which represents this garden? A 2 by 8 garden, 2 times 8 is 16 meters squared. Okay, the next example, we have 20 meters with a width of 3. The length will be 7. You're going to use your algebra skills for that. 3 times 7 is 21. I'm noticing that as I calculate each of these areas, it seems to be increasing in size or increasing in area. Okay, let's keep going here. 4. So if it was 4, using my skills, I'd realize that was 6. 4 times 6 is 24. Oh, it's increasing even more. Well, let's keep going. Next one should be 25, and I use my skills that I'm not going to show here. When I calculate area, 5 times 5 is 25 meters. Okay, let's keep going here. Filling in our data table, 20 meters. If the width is 6, what is the length? 4. And 6 times 4 is 24. That gives us the area. Ooh, I'm noticing that it got to about 25 and now it's starting to decrease. Let's see if that pattern continues. If you'll notice here, just as a quick thing, if my width and length are 7, the opposite would be true. If the width is 7, the length is 3. I just kind of use the opposite there. Okay, 8, 2, 16. Oh, yikes. So what I'm noticing now, here's the piece that you're going to have to really use your thinkers for this. You're going to look at this data that you got out of the table, and you're going to have to pick which one of these is the maximum area. Which one is the largest area? 16, 21, 24, 25, 24, 21, 16, or 9? Well, you know that it's 25 meters squared. That's the largest area. So the largest area that we can make with 20 meters of fencing or 20 meters of perimeter is a 25 meters square area. And you show that with your data table. So it wants to know, let's make sure we understood the question. So the largest area we can make is 25 meters squared. And what are the dimensions? It would be length and width of 5 meters. Gives us the maximum area of 25 meters.